Cool. Thank you for joining me. I understand that the cookies and the brownies are just about to come out, so I really appreciate you being in this session instead. I hope we'll have plenty of dessert anyway. We have very little time. There's been some scheduling mishaps, so I'm going to go through this very quickly. If you have any questions, grab me at the end. We can have a much longer discussion about this stuff. So my aim today is to go through what is GitOps so that you can take it home with you, essentially, and start using it in your company, in your enterprise. I'm Brice. I'm an engineer for the customer success team at Weaveworks. That means I work with other companies on their platform to help them, kind of enable them to build their platform. And Weaveworks is the company behind the GitOps model, the operations model that's called GitOps. So this talk is kind of this conference is kind of about two things. There's transforming cultures and practices, and there's solving technical challenges. This is like the hard, soft problem, right? This is a hard problem. The transforming culture and practice is always the hardest bit of any engagement, any transformation. And then there are, easy, hard problems. So there's like hardware, software, technical problems. This talk is mostly about solving the technical problems of kind of managing your infrastructure, and hopefully there will be plenty of really good talk about transforming your people and your organization today. So I wanted to go back to the roots of agility, which is the Agile Manifesto. If you've come across this, if you haven't, you should go and look this up. But really what it comes down to is two things: embrace change and adjust directions often, right? It's having a tight feedback loop. So the question becomes, how do I do that before infrastructure? How do I actually make this happen, but for managing servers, fleets of servers, etc.? Specifically, right, there are some kind of very specific questions around how we manage our infrastructure. How do I reduce risk of change, right? If I change something, how do I reduce that risk of change? If I add a new service, if I update my OS, if I update everything. I mean, we've just had a presentation from the Oracle Cloud, which says, you let us do it. But how, if you need to manage it yourself, how do I reduce that risk of change? How do you recover in failure case, right? If something goes wrong during a change, how do you recover? How do you empower collaboration within your teams on infrastructure? Traditionally, infrastructure is very limited set of people have access to it. It's very hard to collaborate on infrastructure because it's such a critical piece of your business that it's very hard to give people access to it. So how do you audit changes to infrastructure? How do you enforce quality policies? You might have a set of policies about how you run your infrastructure. How do you do that? And how do you implement a governance process around your infrastructure? So those are all kind of specific questions around how do you get agile infrastructure? And our answer as a company, and something that we've used internally, this is derived from our own internal usage, is GitOps. So GitOps is an operations model. It's the best thing since configuration as code, apparently, or so we're told. But essentially, it's an operation model that's derived from computer science and operational knowledge that we've gained over time. So we've been operating Kubernetes specifically for about 4 years now, and a lot of those things have been learned while we've been building our Kubernetes platform internally. It's fairly technology agnostic, so it's not really about Git, the tool. It's more about the why instead of the how, right? So it's about the why. Although obviously, like people like Weaveworks, the company, can help you with how. GitOps itself is about the why, not the how. And the core value is to speed up your team. It's to get your team to go faster when it comes to infrastructure. How do you innovate and iterate on infrastructure faster? So practically, traditionally, what you would do is you'd have a piece of infrastructure, and you would give your developers, your administrators, your database admins, you'd give them direct access to your infrastructure. What we're doing here is changing that model, so you no longer have direct access, or at least this is no longer the default way of operating on your infrastructure. Instead, what you have is you have a configuration repository, and that becomes the default way of operating on your infrastructure. So you're moving direct access, which is very hard to audit, very hard to track, very hard to manage, into here's a set of configuration, and then we're going to drive our environment through configuration. And then you have this repository of your configuration. This is like your desired state. And then you have an agent that takes that desired state and implements it in your infrastructure. And here it's quite interesting because the agent, and I'll mention this now and come back to it a little bit, the agent is actually inside your security boundary. So if you're in a regulated industry, and if you've done any security audit of what we call CI ops, where your deployment, when you're moving code into your infrastructure, or when you're changing your infrastructure from your automation tool, the access control story over who gets to change the infrastructure could get very complex and very difficult to manage. Here instead, the security role, the authority to change the system is within the system itself, so it resides within the security boundary of your system. So we have this flow, right, in one direction from your configuration to your system. And you also have artifact repository. These are immutable artifacts. In our modern cloud-native world, that's containers. You have immutable containers. They do not change. The same named container will always remain the same content, the same binary file. So these are immutable artifacts. So you have an artifact repository, you have a configuration repository, and you're driving those two things into your infrastructure. Those could be operating system images, right? You want to be doing immutable operating system, immutable machines. That is how you do it. You have a repository of immutable images, and you drive those into your infrastructure. And this is where the agility comes in, right? This is where we start to care about operations. Because we don't just push things in one direction. What we actually have is we have continuous monitoring of the system and the configuration. So we essentially have a control loop here, right? Agility is essentially, you get agility through tightening feedback loops in your organization. This is a feedback loop. This is like your innermost feedback loop that's actually controlling from your configuration and your system and making sure that the system always matches your desired configuration. So, for example, if you're on AWS, you might have used CloudFormation. CloudFormation has the way of differing, of looking at the difference between your desired state and your actual state. But this is a manual process. I, as an operator, a human, I have to go and click the button to watch the difference on my screen. This is not what we're talking about here. We're talking about continuous automated checking that the system and the state match, and actually your system is doing the thing you desire it to do. So this relies on kind of four major principles. So the first one is everything is described declaratively. Your entire system is described declaratively. More pragmatically, you describe as much as you can, because there are some existing tools that you're going to be using that cannot be described in that way. One notorious example is certain sets of network switches, right? If you have a Cisco switch, there are still some switches that are being sold whose only means of configuration is to log in and run a set of commands. That is not very declarative. That's very hard to kind of set that up. But essentially, you're wanting to declare your entire system as much as possible. The canonical state is versioned in Git, which is why we call it GitOps. So you version your system state. And then the approved changes to those versions. So when you create a new version, you create an approved new version, there's an approval process for that new version to be accepted. That gets automatically applied. And the real key here is that once that's automatically applied, you have an agent that tied in a loop that is continuously making sure that your infrastructure matches your configuration. So everything is described declaratively. This is beyond code, right? This is not infrastructure as code, it's infrastructure as data, or data-driven infrastructure. So it's implementation independent. It's much easier to validate data than it is to validate code. If you've ever tried to validate code, you'll hit the halting problem pretty quickly, which is a fundamentally difficult problem to solve. Whereas you don't have that problem with code, right? With data. Data doesn't have that problem. It's very easy to validate data in a way that validating code isn't easy. Everything is versioned in Git, right? Everything is in Git. Everything is versioned. That way you have a canonical source of truth. Don't repeat yourself, right? It's a principle of software development. You're applying that principle to knowledge about your infrastructure. It's trivial to roll back. Because you have declared changes, essentially you can start thinking about rollbacks and roll forwards as transactions, just the way you do with databases and data. You're transacting from one known state to another known state. So it means that in the failure case, you can just bring it back to the known good state that was there previously. It's really good for auditing. Git is one of the best auditing tools you will find. It tells you who made a change, when, why, and how. Right? So you have all those 4 pieces of information in an immutable log that is cryptographically secure if you set it up properly. I challenge anybody in this room or in this conference to find a better system for doing this particular this particular job. Right? That is an excellent system. I can have a discussion of why I hate the term blockchain, but essentially that's what we're talking about here. We're talking about a Merkle tree that is cryptographically secure history that is immutable. And we already have phenomenal tools to implement workflows and processes on top of this system. Right? Git already plugs into a whole bunch of approval workflows, automated checking. All of that stuff already exists that we use for code quality assurance, and for managing code itself. We want to apply that to infrastructure. Everything is applied automatically. This is what you get your velocity. It separates what and how. So what is applied and how it's applied is separate. What is applied is declared. How is applied is your agent in your system that's making those changes. And then you have that continuous checking, that loop, that tight in a loop that is continuously checking the state of the system. Now this is a really good way of avoiding picnic error, problem in chair, not in computer, right? So this is operator errors, right? This is a good way of making sure that operator errors don't cascade into your production systems. So it's the control loop for your operations. How are we doing for time? Okay. So here's a concrete example of a CI pipeline that is traditionally built. And one thing you'll notice here is that the CI pipeline has write access to your environment. Now that's a security nightmare. CI pipelines are designed to allow remote code execution. They are not a good security environment. So what you do, you move the control into the system itself, and you have that controller react to a declarative configuration automatically. So you have the canonical state stored in that configuration. The controller reacts to it and changes your system. And then the operator, and that could be a human operator or it could be a software operator if you want to do automation, then makes changes to that configuration repository. And this is a single enforcement point for your process and governance, right? So you can start creating your process and your validation and your policy application in a single spot. And it's very sophisticated. The policy tools that exist around configuration like this are extremely sophisticated, more so than what we're used to in the policy space. And they are verifiable policies, right? These are kind of things that you can verify are correct. You can test them to be correct because you're essentially comparing 2 pieces of data. And you have phenomenal auditing because we've already talked about Git's auditing capabilities. So what should we actually bring into this approach, right? What should be GitOps? So everything to do with your applications, right? Everything that runs in your application. Everything that runs in your configuration of your servers, but also your process documentation. Things like your dashboards, your alerts, the pipeline for your monitoring data. Your secrets should be versioned. You should be able to roll back secrets. Your runbooks, right? These are your documentation for your operators. And why do we want them in the same kind of context? Well, when you change the system, you change how it should be, the documentation for it, for the operator. Those 2 changes should be correlated, should be made in the same change set, because it's the same set of logical changes. You change the system, you change the dashboards, you change the alerts, you change the documentation and the runbooks. All of that together as a single change set. So all the things that could be that describe your system and that describe how to operate your system. So we get trivial rollbacks out of this. We get really good auditing and attribution. Not just good, exceptional auditing and attribution. We get separation of concerns. How you build your immutable artifacts and how they are deployed to your environment, separate concerns. Don't use the same tools when the tools are built as build tools that are designed to create artifacts. Those are not automation tools. Jenkins is not an automation platform. Jenkins is a build platform. It should be used as such. Use the tools for what they were supposed to be used so that you don't have a friction when you're operating on your platform. Don't cross security boundaries. The keys that give access to your server farm to create and manipulate your system should not live in your CI pipeline, right? Make sure that's inside your safe zone. Enforce, you can start having a place where you can enforce process, enforce policies and governance, and a single place, single location. And you can start collaborating with human and software, because all that configuration can be written to by a human, written to by a piece of software, and the two can collaborate together. And in fact, that's what we do internally, right? Our control repository, our configuration, sometimes it's a software that makes a commit, sometimes it's a human. Same process, same validation, same tools, modularize it so it's extensible and more powerful. And finally, it's very easy to validate for correctness. We've already talked about this. Okay, so what does that look like in a real transformation? This is what happened to a company that adopted this approach. A real company. These are real charts from their bug tracking. Time needed to fix production bug reduced. Time to market, time to respond to customer requests reduced. Uptime went up. This is really interesting. They went faster with fewer defects. Traditionally, you'd expect that to not be possible. You'd expect if you go faster, you're going to break stuff, you're going to have more defects. That is not the case. It turns out you can go faster by reducing defects. In fact, they went from about 2 deployments to about 150 deployments per week. We internally, we do dozens of deployments a day, several per hour during the working hours. So why? Well, it's because of the OODA loop, right? That observe, orient, decide, and act loop, that's the loop you have to go through to kind of move things, to move your infrastructure, to make decisions. Well, in infrastructure, that's what it looks like. And essentially, that's where this started. And we automated the rest with things like software making commits to modify more quickly, safe and reversible change, and the safety of a change. We talked about fear earlier in various talks. Right? Fear is one of the problems with agility. Right? You can't be agile in a state of fear. You need some security so that when mistakes are made, they can be rolled back. If a mistake is made and the consequences are going to hurt you long term, you will not be willing to change, not be willing to adapt. And then you have automated templated dashboards so that you automate the view of your system. The observability is automated too. So there's a feedback loop latency. That's what actually matters. We don't really have a lot of time, but I do want to mention that this can be applied to the business domain as well, right? This is not just applicable to the technical domain, the infrastructure domain, but you can apply it to your business domain too. In particular, your business intelligence. Why is that not versioned? Why is that not defined? Why is that not reversible, right? Your org chart, your operations manual, your playbook, your security policies, your roles. Why are your roles not defined? Why do you not validate the roles in your company? Why do you not have a unit test that checks that the company roles are covered, right? Why do you not have unit tests on your organization chart, right? Because you can do these things. These things are possible. They're within our grasp to kind of do some of these things. Now, obviously, this is kind of further ahead, much wider scope, but this might be interesting to think about. Okay, that was it.